Welcome to the second lecture in English 193, Communication in the Sciences. What's so abstract about the abstract? Now, the cheeky title of this lecture aside, this is a somewhat serious question because as science students and eventually practicing scientists, you will have to submit an abstract at some point, possibly within your career as a student or hopefully immediately before you graduate as you're looking to join a research team or a project and looking to present your work either in the context of a conference or a research publication like a peer-reviewed journal. The abstract is an essential piece of communication, although it tends to be one of the most dreaded, and we'll go over some of the reasons why that happens to be. Just some things before we get into the meat of this is that this is both a practical and a technical lecture. So I'm going to talk a little bit about what goes into the abstract, but then also do some text level analysis, or what we call in English and the humanities a close reading. Let's go over the purpose of the abstract first and get the big questions out of the way. I always like to start with a quote or two, and these next couple of quotes deal with just the concept of abstract and abstraction. Abstraction forces you to reach the highest level of the basics. Alan Soffer. Now, this is also a little bit of a cheeky comment because generally we think of abstraction in one of two ways, and oddly enough, they tend to be quite opposed definitions of one another. Either we think of abstraction as being something that is simplified and distilled down from its more complex natural way that it appears in the world, or to abstract something means to actually pull it further away from recognizability and therefore make it more complex. So Soffer's quote here alludes to the idea that by learning abstraction, the art of abstraction, we attain the highest level of performance of performing the basics of whatever that is. But the point here too is that by moving into abstraction, we can often pull out what are the really most important components of any idea and learn how to communicate it better because we know what's essential about it to get across to our audience. Next quote, writing is an abstract art of drawing pictures of the conscious and subconscious mind with words. Now this one's a little bit more deep and poetic, but if we think of writing as basically making pictures in the mind of our readers, then we deal in abstraction all the time when we write because no one is going to see in their mind's eye exactly what we do or necessarily all the things that we want to communicate about a given subject. So when we choose to write something, we have to make several decisions right away that kind of pare down the idea and make it more digestible, or we present it in a way where we build it up and scaffold it. So we start with something very simple, and then we keep drawing that picture, adding more and more details for whoever our audience is. So as we move into talking about composing an abstract, I want you to think about this idea of kind of filling in the picture or painting that canvas in the mind of your reader, and the ways in which we might do that create a lot of interest and dynamism, but also keep it kind of short and to the point. The purpose of an abstract, number one, is to outline the importance and relevance of your research. We can think about the abstract actually as an outline, except not in bullet point form. If you were to take an outline and then add 2 or 3 sentences to each point in a bullet point list and flesh them out and really sort of explain why they matter in relation to one another, that is the essence of an abstract. We also want to do this in a condensed and concise way. And a big part of this is taking all of our methodologies, the ways that we're actually conducting our research, and finding ways to describe them that don't go into the same level of detail as we would either in the article itself or the presentation, but still do it in a way that really makes it clear what is the most important method and why is it being used. An abstract also communicates some key sound bites that make the research notable. So in the abstract, we want to immediately encounter why the research matters, and then usually some kind of language that is memorable and will stick with us so that we can attach the facts that are presented in the research to something that tugs a little bit more on ethos or pathos. Lastly, an abstract should convey a sense of your voice. So it shouldn't be a toneless, sort of robotic description of your research. It should include, of course, appropriate to your audience, tone, register, and narrative, or that story that we've been talking about, to communicate your unique perspective and how it situates itself within the broader field or discipline that you're working in as a scientist. Here are some facts to consider where we are at in terms of the abstract and science communication. So, more than a quarter of scientific abstracts published in 2015 had a readability considered beyond graduate level English, compared with just 16% in 1960. So, let's break this down. Graduate level English. All of you are undergraduate students. So now imagine that you are in your master's, but you've switched majors completely. You're no longer in the sciences, and you're now in an English program where you're expected to have read tomes of classic literature, have this expansive vocabulary, be able to conjugate verbs in 7 different ways, all of that. And what purpose does that serve in terms of getting the real message of what your research is about and why it matters across to your audience? Well, often it doesn't. And so, compared to 1960, thinking back now almost 60, well, exactly 60 years ago, only 16% of the abstracts sampled from that period had that same sort of dense, complex readability to them. So, what's been happening is that in the abstract, this sort of very already kind of mystical, convoluted piece of writing that most of us dread having to do, instead of making it easier for our audience and just kind of approaching it from a very straightforward and practical kind of perspective, a lot of us tend to jam it up with unnecessary amounts of fancy words, and we end up making it much harder, less readable for the person on the other side. Also, more generally, the complexity of scientific writing is increasing with time. And there is actually, according to this study from Sweden at the Karolinska Institute, that there is a strong positive relationship between readability of the abstracts and the full text. So if you write your abstract densely and in a way that is using lots of abstract verbs and abstract nouns that don't do a good job of clearly telling a story, then that same style of writing tends to carry over into how you write the full text and or paper presentation. So setting the tone in your abstract is really important, and we're going to explore now some things that you should avoid. Common mistakes. The number one thing that we encounter in science abstracts more generally is that they're overly wordy. And this doesn't just mean using complex vocabulary or terms that the layperson wouldn't encounter normally. It just means that there's a lot of words. So cutting down on the amount of words it takes to say something and making sure that the sentence structure is as efficient and effective as possible with less words is a really important tactic. Like I mentioned on the previous slide, cutting back on abstract nouns and specialized terms is going to help your reader immensely. It doesn't mean that you can't use any abstract nouns, but be very conscientious of how often they come into play. And another thing that plagues many abstracts is too much quote-unquote jargon. Now, jargon is a negative, almost pejorative term for actually the key words that many scientists in different disciplines use to communicate with one another to make sure that they're on the same level of understanding about a topic. So it can be very helpful actually when you're conversing with another scientist who's familiar with your field and maybe even your particular research topic, because the jargon are these dense words that often hold a lot of meaning packed tightly into those letters. But to the average reader, even the person who is, let's say, a scientist but in a neighboring field, the jargon often has a negative effect of creating this rift between you and them. And that's why I've chosen this illustration here, where it's almost like rather than having a very intimate face to face conversation, you're sort of out at sea on two different boats shouting through megaphones at one another. And only some of that sound is going to make it across to the other side. And there's going to be misinterpretation probably because of that ongoing distance. Another big thing that we see in science abstracts is that they're just not compelling. And hopefully in the previous exercise and lecture, you've seen the value of using rhetoric in order to make your research more compelling and more appealing, not only to a broad public, but even within your own field in terms of stating why it matters and to whom. We see, like as Green points out in the textbook, there's a lack of characterization. So we're not in science very good at telling stories and making the subject of our research also the character of a story. And we see a lot of weak verbs and passive voice. So rather than saying things like, I will interpret, we say things like, the data will be interpreted by. And that's a way of sort of removing ourselves, not only from the equation, which is a falsity because we are the researchers doing the research, but it also creates just more convoluted sentence structure, and it actually takes the subject of the sentence and positions it further away from the verb. So it's harder for the reader to make those ideas connect. Sorry, passive voice was supposed to be involved in that last little spiel. And then two more things that are common mistakes. There's a lack of flow. So you've probably seen this for yourself if you've read an abstract from a research article, a science research article, where there are these turns very abruptly from one idea to another, and it doesn't seem like there's a good transition. And this is really apparent, especially when we go from stating something that is data-oriented and a kind of quantitative piece of information that relies either on an equation or a statistic or a percentage, and then we switch our register to talking about maybe what are the implications or what others in the field are doing at the moment to address it. And there needs to be some kind of short transition that's crafted that happens at the end of the previous sentence before the next one, so that the reader can see, in a way, how you're thinking about those ideas connecting, but on a more practical level, it just makes the reading experience easier and less taxing. And then lastly, and this is a big one that I'll be stressing in a couple of minutes, generally, the implications of a science abstract are just unclear. It's the section that scientists tend to spend the least time on when they're crafting their abstract, but it's one of the most important because we talk about our research, but then other people want to know, well, how does it matter to them? So they're not the ones doing the research, but they might be working in an adjacent field. So how is your research going to impact them? What are the implications of what you're doing? So it's not just stating the findings, but also thinking about how it reaches out and relates to a broader context and how it fits into that puzzle. All right, let's move on to the meat of this lecture. Sorry, bad pun there. With the anatomy of an abstract. So here we're going to break down, at least according to me, after viewing a number of different sort of opinions on what needs and should go into an abstract, here is a formula that I think will work almost every time. There might be some exceptions, but I'll talk about that a little bit as we go. So number one, in our imaginary abstract, you need to establish the reason, not only for your research, but also for its presentation. So why are you bringing it into this public forum, whether it's in a publication or a presentation? So like I have over here on the right, this is confined usually to the first sentence or two. I wouldn't go past that though, because we'll delay getting onto the other sections of the abstract. And again, most abstracts, rarely they can go up as high as 400 or 500 words, but most of the time we're talking about 200 to 250 words. So really, about a half a page is all you have. So in the first sentence or two, communicate the reason why your research matters and why should the reader care. It doesn't mean that you have to appeal necessarily to an individual reader. Try to be general and say, okay, world, this is why it matters. It connects to these bigger ideas. Next, then you present the problem, which is very much related to the reason. The reason is a little bit bigger in scope. The problem is the specific thing that you are looking at in your research. So this might be actually, let's say that you're doing something in microbiology. The reason is the sort of general field or subfield, and then the problem itself is whatever that, let's say it's a disease, or perhaps it's a particular stem cell property. Those sorts of things come in with what is the problem that you're investigating specifically. And this next section needs to play off of that first one with a nice smooth transition. Again, limit it to a couple of sentences. And one thing to think about here is that it's the central issue that faces the research, if that's a helpful way to phrase it, or compels it. What actually motivates the experimentation that you're doing. The next section is probably very familiar to you and one of the most important, and it comes nicely in the middle, devoted to the methods, and or alternately called the methodology. So this is where you establish what methods you're using, but also a good abstract briefly mentions what other existing methods are out there, or perhaps somebody else's work that you have looked at as part of your own research process and that you're either playing off of or that you're strategically sort of countering in the work that you're doing. Next, we state our findings. This is the one where a lot of science students get tripped up because the temptation is to state all of your findings in the abstract and really make it kind of, because it's the first thing that somebody will see before they read your paper, or it's the thing that somebody will vet and filter before you get accepted to a conference. There is this temptation to pour all of our findings into the abstract so that we can kind of show off and say, haha, look at all of these things that I did and I discovered. But the findings section should probably have one, maybe two significant findings in it. Keep in mind that this still needs to be a concise and clear abstract, so no minuscule details at this point. Only what you want the reader, again, to really take away, possibly memorize as they're sifting through many abstracts, and then go, oh, there was that really important finding that was stated very clearly and concisely in that abstract, and now I'm going to go back to that paper, or I'm going to give those researchers a chance at this conference. And then lastly, I talked about this a little bit in the last slide, but the implication section comes last, and arguably it's the most important, because you briefly state what the findings actually contribute to your overall field. And then this is the part where many science students also kind of drop this last important bit. You include any of the potential practical applications. And I know that by training, scientists are not ones who go out on a limb and say, well, it might do this or it might be applicable to that. But that's another reason to consider in your research, you should also be surveying and scanning the field and thinking about actively while you're conducting your experiments and looking at and compiling your data, how your research may actually affect practically what's being either produced, what other, I'm getting a little tripped up here just because I'm trying to think of a very specific example, but because you're all in different branches of life science, it's not that easy. So I'll just say this, that the practical application is supposed to be specific, and it would be good if you can point to, let's say, something that is already existing either in the scientific community or in available to consumers in the broader public that your research will either influence or it will add to, and like I said, contribute to your overall field. And this implication section is often the one that when somebody is vetting an abstract, this is what they will remember. So rhetorically, it is probably the most important section. Another way to think about organizing this abstract and the anatomy of it, we have our 5 different sort of sections or key points, but you can also use just 3 simple questions to organize this process as well. So the reason and the problem sections define, or answer, I should say, what is at stake in the research. That's a very clear way to ask yourself what, not only why it matters, but what is going to be the consequence, or could there be negative consequences if this research is not practiced and taken up by the broader community. Secondly, in the methods and findings sections, we describe or answer how do we know this. So once we've defined what's at stake, then how do we know it? And that should be a very clear way to lead into stating your methods and findings. And then lastly, the implications, again, is a little bit more speculative, but not in a fictional way. So where do we go from here? And it is okay for scientists to speculate on the applications and implications of their research as long as you do it truthfully and you're open about that speculation. I don't think that there's anything wrong with the idea that scientists can be somewhat creative in thinking about where their research goes after they've conducted their experiments. It's just all about being transparent and being accountable for that. All right, so I'm going to pause here before we go into the close reading and do some analysis of an abstract, and we'll pick back up on the other side in the second part of this lecture.